Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. Hey, what's up everyone? I recently attended the AWS reInvent conference in Las Vegas, and I'm excited to share a few of my many interesting conversations from that event here on the podcast this week. Before we dive in, I'd like to thank our friends at Capital One for sponsoring our reInvent series. Capital One has been a huge friend and supporter of this podcast for some time now, and I'm looking forward to sharing my interview with Dave Castillo, Capital One's Managing VP of Machine Learning, with you on Thursday. Dave and I discussed the unique approach being taken at the company's Center for Machine Learning, as well as some of the interesting AI use cases being developed at the bank and the platform they're building to support their ML and AI efforts. Once again, check back in on Thursday, December 19th for that conversation. To learn more about Capital One's machine learning and AI efforts and research, visit capitalone.com/tech/explore. And now, on to the show. All right, everyone, I am here at AWS reInvent in Las Vegas, and I am with Ville Tuulos. Ville is a machine learning infrastructure manager at Netflix. Ville, welcome to the TWIML AI podcast.
Oh, thanks for having me, Sam.
I'm really looking forward to jumping into this conversation. It turns out our timing could not have been better. Your team just announced a new open source project called Metaflow that we'll dig into. But before we do that, you mentioned before we started that you've been working on machine learning infrastructure since, what did you say, 2010?
No, actually like 2000.
I'm sorry, 2000.
Yeah, 2000. I mean, it's kind of, I guess I date myself. But yeah, no, I've been doing this for a long time. When I started, even the term data science didn't exist. Back in 2000, this was just during the dot-com boom. I was at the startup that tried to commercialize neural networks. Neural networks really weren't that popular back in the day. We were way ahead of our time. I mean,
what was the startup called? Will anyone have heard of it?
No, I mean, it's called Gurusoft.
Okay.
So no one, and actually it's probably better that no one has heard of it. But I mean, it was a great lesson learned. I learned a lot. And ever since then, I've been working with data scientists, people who want to build machine learning, people who need help with infrastructure, who want to kind of scale, who want to make it better. So, I mean, it's a super exciting topic. And now it is, of course, absolutely mind-blowing that the whole topic has become so popular, and it is on top of everybody's minds, it seems. So, but yeah, no, I'll just keep doing it.
Yeah, well, it's certainly a far cry in popularity from 2000.
That's right, yeah.
What was your background? How did you end up doing ML infrastructure?
Right. So I have a master's in computer science, and I was part of a research group. I'm originally from Finland, so I was working at University of Helsinki. We did many things related to Bayesian statistics, information retrieval, things like that. And I was always gravitating towards thinking how we can make these things easier. I mean, there were people who are absolutely amazing on the theoretical side of things, and I realized that, many of the things that people were already doing back in the day, I mean, the fact is that machine learning is not a new field per se. Mm-hmm. It was only kind of blocked by the fact that it wasn't easy enough. It wasn't easy enough to apply these things. It wasn't easy enough to scale them out. And that was really kind of the bottleneck in the whole process of making these techniques and methods more applicable to more real life use cases. And it seems that now, I mean, 20 years later, I mean, things are much better. I mean, especially off the shelf machine learning libraries are absolutely amazing these days. But I mean, I still think that there's work to be done. That's why we open source Metaflow, and that's why I keep doing what I'm doing. So.
Let's dive into Metaflow, and maybe the place to start is paint us a picture of the context, out of which Metaflow grew and what the problem is that it tries to solve. This was just announced yesterday. So,
totally, 20 hours ago.
Probably not many people will have, heard of it.
Yeah.
By the time people may have heard of it by the time this is actually published, but as of today, very few have.
So let me start by giving some context. So as you and like many of the listeners may know, Netflix has been doing recommendations for a long time. So when you log into Netflix.com, you see all the TV shows and movies that are recommended to you, and obviously that's done by a machine. It's an algorithm, not by people who choose like what to show there. And this is something that like the company has been doing for a long time.
Sure.
And now a couple of years back, I think it was about 3 years back, like we started having the realization that more and more of machine learning use cases were actually happening outside recommendations. So of course, Netflix is now probably like one of the largest movie studios, TV studios in the world. And like we have appetite to just like apply data science, machine learning in all kinds of different areas. And like the first question we ask ourselves is that can we use the existing infrastructure that we have for recommendations for these other use cases as well? And we are talking about things like natural language processing or like operations research, optimizing production schedules, things like that. And the realization was that these things are actually quite different, like from the production scale recommendations that we had. And we started thinking that actually we need new kind of infrastructure that helps data scientists that are working on these more internal use cases. And that was really the context, the motivation, like why we started building Metaflow. And then when we started working on this, or when we started thinking even like what to do, the interesting thing is that there is like 2 years back when we started 2017, there wasn't much available in open source or even as commercial products out there. And we started asking ourselves the question that like, what are the things we should be doing in the first place? And quite soon the realization was that technically many of these things were kind of possible. Netflix, of course, has all kind of infrastructure already available, but nothing was easy enough. And that's when we kind of, in a way, a light bulb went off in our heads that like our job as the machine learning infrastructure team is to make things easier. It's really to be human-centric and like increase the productivity of data science instead of saying that like, look, we can build larger scale models than anyone else.
You contextualize this as making the data science process easier. When I talk to folks that are building ML infrastructure, it's not always clear who their primary audience is, whether they think of it as data science or machine learning engineering. Is that a hard distinction for you, or who are you supporting with Metaflow?
That's a great question. So now the people who we support are data scientists, and like really data scientists who are absolutely capable, who are the world's best experts in building statistical models, building machine learning models. But oftentimes they don't have a background in computer science. So they are not software engineers. So they are like very classical, like a scientist with capital S in that sense. And our job as the infrastructure team is to provide them with enough tooling so that they can be experts at the kind of really at the level of data science, like build the models, and then they wouldn't have to worry too much about the software itself. Now the thing there is that like the Netflix's culture is quite special, and like we want people to operate the end-to-end machine learning workflows independently. So it's not so that the data scientist builds the model and hands it over to machine learning engineer who then pushes to production. But we want this data scientist to own the project, like from the prototype to production, like from like kind of all the way, like kind of from the raw data to kind of the business results. And of course, this is very hard, like if you don't have the supporting infrastructure, and that's where we come in.
So maybe another bit on context to, when I think about Netflix, having followed the company for many years, the company's been very active in open source, particularly with regard to the way that it does cloud infrastructure generally. Chaos Monkey and lots of projects have been great contributions to the community, as well as interesting projects on the data science side. Papermill is the one that comes to mind most immediately. Maybe talk a little bit about, if we haven't really defined Metaflow and like what it's doing beyond it's a platform to support data science, but talk about why it was important for your team to open source this as opposed to build it to support the internal use case.
Yeah, that's a great question. Now, as I mentioned, we started about 2017. We started with Metaflow. And as I mentioned, like the motivation was really to help data scientists be really human-centric, human-friendly. We started building this Python library. And now over the past couple of years, this has become really popular, like inside Netflix. And we have given a few conference talks about this outside Netflix as well. And every time we went out and like talked about Metaflow, we got like really great response. Like people in many other companies felt that like something like this is absolutely needed. Of course, the need is very common. Like how do we make data scientists more productive? And now another interesting angle, like you pointed out, that Netflix has been doing open source for a long time. Also, another thing about Netflix is that we have been a user of Amazon, like Amazon Web Services, AWS, for a long time. Metaflow, like from the get-go, was built to support the cloud and like was built to really work nicely with the cloud. And the combination of having something that like really like makes data science easy for people who are not software engineers, as well as leverages the scalability of the cloud, was really something quite unique. And now, when we really decided that we want to open source Metaflow, we actually started also working with AWS to make sure that people outside Netflix can have the same seamless integration to the cloud that we have been enjoying internally at Netflix. So now it's really the kind of the combination of the productivity and the cloud integration that I think that like makes Metaflow a very interesting package today as open source.
Let's talk about its functionality. What are the core features that Metaflow is trying to offer to the user base?
Yeah. It's almost a paradox in the sense that we say that we are a machine learning infrastructure. And there's one thing that like we are kind of not too opinionated about, and that's machine learning. So also an important realization is that there are absolutely amazing off-the-shelf libraries these days, like TensorFlow, PyTorch, scikit-learn, XGBoost, and we use all these libraries internally. And we absolutely don't think that like we can provide anything better than what you can get from those libraries. Also, we feel that it's very important that data scientists have the freedom to choose the libraries, kind of the best tool for the job. So that's one layer. But as you know, the models themselves are only a tiny part of end-to-end machine learning pipelines. And what Metaflow does is that it kind of helps you with everything else around the models. So all the way like from how you access the data, like to how you execute the compute in the cloud in very easily, so that like you don't have to learn new paradigms. You can just write idiomatic Python code. You can just use the off-the-shelf libraries. We take care of packaging everything. We take care of like scaling it out to the cloud. And especially what we do, and this is like really one of the key features of Metaflow, is that we automatically snapshot absolutely everything you do, including the code, the dependencies, and the data that like flows through the kind of the data flow. And why this is important for a couple of reasons. Now it allows you to reproduce results afterwards. And also it allows you to inspect any internal state of the model. And this is really important that machine learning models, as any software engineering artifact, they never like work perfectly, like kind of at the first deployment. Mm-hmm. So it's always an iterative process. And we feel that it's really, really important that like we provide first-class support for debugging and troubleshooting. And that's why having the snapshots in the cloud is so useful. So this is kind of the package that Metaflow provides, like really from end to end. And like then you can like do the modeling as you want to do it.
Well, let's maybe start at the data and walk through that in more detail. What are all the features that you're providing kind of, or maybe another way, a better way to ask this is, what is the user experience from the perspective of, accessing data, managing data, creating transformation pipelines, things like that?
Yeah, that's a good question. So now Netflix has a very mature data warehouse that's based in Amazon S3. So we have hundreds of petabytes of data in Amazon S3. And also we have various query engines that we use, like Presto and Spark. And of course, like many data scientists are quite comfortable using SQL to access data, so we support that. So you can use any libraries you want to kind of access. I mean, many companies who might want to use Metaflow, I mean, they probably have Spark or Presto, and that's a totally valid way to access data. Now, one very specific optimization that we provide is that we notice that oftentimes in these machine learning applications, you kind of just want one big data frame. You want kind of everything. So and then like you want to decide how you do feature engineering inside your Python code. So we provide this extremely fast path, which we call fast data, that allows you to pull data directly from S3 to your machine learning workflows, like very, very fast. So we are talking about 10 gigabits per second. And this feature alone has been really, really popular amongst data scientists, since previously they used to wait for 10 minutes, 20 minutes to get the data, and then they could actually study trading on the data and so forth. And now you can get it in seconds. So that really is a big like boost in productivity that we provide. And then, as I said, we are not too opinionated. We are not like proposing a new paradigm for data processing. This is not yet another MapReduce or anything of that sort. So you can use all the tools that you like. You can use Pandas. We also heavily leverage the Arrow framework, like for managing in-memory data frames, and then like you can just like in your normal Python code like do the processing you like. So now, of course, the question that might be going on in your head is that, well, I mean, how does it scale? Like how it works if you have massive amounts of data? one realization that we had is that also at Netflix, not everything is absolutely like massive scale. We have many use cases where the data actually fits in memory when you are a little bit careful how you handle the kind of the data representation. And the example I always use, that if you imagine that today Netflix has about 150 million accounts, if you have a data frame with 150 million rows and then like 1,000 columns, maybe we are talking about 150 gigabytes of data. So which is something that you can hold in memory on a large machine. So then you can just treat it as a big pandas data frame or something of that sort, and it just makes life very easy. Obviously, I mean, it doesn't work for the largest scale use cases, but it definitely works for 80% of use cases.
So the fast data abstraction is primarily focused on getting information in from S3 quickly and making it accessible to the rest of your Python code. You kind of describe this as an optimization. How do you optimize that if it all lives on the cloud and much of it beneath your kind of control horizon?
Absolutely, and that's a great question. And now, one like unique perspective that we have here is that Netflix has been working with AWS for more than 10 years. So we have a lot of operational expertise and experience how to deal with AWS. And the fact is that AWS is amazing. It's very easy to use, but there are also certain things that just make life easier if you know how to do it right. And like these best practices are something that we baked into the Metaflow. So for instance, for things like S3 access, there are like ways how you handle multiple connections to S3 so that like you can maximize the throughput, things like that. Absolutely things that we don't expect that like any data scientist and not even more software engineers know about. But I mean, things that like we want to provide as a service. So
it sounds like you're counting on folks doing ETL and data pipelines and Spark and other things. You're not offering some new infrastructure for that. Are you doing anything around like a feature store or some way for data scientists to collaborate on data pipelines?
Yeah, I love that question. Well, now the short answer is surprisingly maybe no. And like we have been thinking about that a lot. And one thing that we do feel very strongly about is overall the question of collaboration and like how do we enable people to collaborate. And like we provide a lot of tooling to help everyone to first organize their work. So then, and actually it happens pretty much automatically. So you automatically, everything you do, I mean, it gets persisted in the cloud. Anybody else can see what you have done and they can build on your results. Now at the same time, collaboration is actually pretty hard, and like in general, and in particular in data science. And the reason for that is, let me just give you a practical example that if you have a data scientist, let's say, who builds some amazing embeddings, like that, like these are the ways how we can characterize, let's say, some content or something, and now like someone else could potentially benefit from these features. Well, that works all good and fine, maybe like kind of during the first iteration. But now what happens if the original data scientist who built these embeddings decides to like change something upstream? And now, of course, like you have this trickle effect to everything downstream. And it takes a lot of discipline to actually now manage the upstream so that like these effects don't have any adverse effects in the models downstream. And there's like a difficult trade-off between the stability, like kind of, okay, being really stable so my consumers can consume my features versus then being able to iterate fast.
Right.
And like we have been always leaning kind of on the side of allowing people to iterate fast because ultimately that is really, really like what matters. Like many of these things are very experimental. And then like only in some like very rare cases, we understand that this is something like in some specific domains that like now we should make it so that like more people can start like sharing the features or like maybe code that generates the features rather than the features themselves. So we have a bit like a shied away from like being a super prescriptive, like how one should like store the features. Also the realization in our case is that we are supporting hundreds of different use cases, and what features mean for NLP is different what features mean for some like statistical like experimentation design pipeline, which is different than what it means for operations research. So it's very hard to be prescriptive about that. But I mean, we are always keeping our eyes and ears open, like kind of how we should go about doing it. So.
You definitely raise an interesting point there. A lot of the work that I see happening in the platform space is trying to drive this idea of reusability with, either things like a feature store and reusing features or reusable data pipelines or like an embedding store, things like that. But the kinds of things are best done when the teams that publish those treat them as products, right?
Yeah.
They're contracts, right? And often there are
implicit assumptions that are made in the thing that are hard to communicate. And if someone takes it off the shelf and tries to use it, they need to really know about those kinds of things. And you mentioned the issue of when the original user wants to evolve the thing, like, the complexity is multiplied by the number of folks that have ended up using it. So it's interesting to hear that the solution that you've chosen is to just not address it all.
Or like let users to kind of maybe kind of manage it bit by themselves. Also, the kind of the question I would like always to ask when people, and like you believe me, I mean, people ask about this all the time, even like data scientists at Netflix that like, well, can we have something like that? I think like one reason like why people feel in many cases that it is really important is that like when things are slow and when things are hard, reusability of course becomes super important. Like if you feel that, I have to spend like 3 hours doing this, then it would be amazing if I could just get it off the shelf. Absolutely, it makes sense. On the other hand, like if doing something takes about 15 seconds, I mean, then the reusability isn't quite that important, because if it's just easy enough, I mean, then like you can just do it by yourself and you get exactly what you need. So there's this like an interesting kind of a question that like everybody should be asking, that like, is it that like we need the reusability only because like everything is so hard and maybe we should like fix the root cause, which is that things are too hard in the first place? Or is there like some actual need for reusability, like when it comes to features and pipelines? And now the thing is that like I absolutely do believe that like we need reusable data pipelines and features for specific domains. So if you have a use case like recommendations, or in my previous life I've used to do real-time bidding, stuff like that, I mean, totally makes sense. But then like the use cases that we are dealing with are oftentimes more experimental in nature. And it's just a question like where you are like kind of in the life cycle of your project. And I think that the sharing like comes at much later stages of the project than many people imagine. So.
Yeah, and an interesting middle ground that I've seen work pretty effectively is to, when folks don't want to build a bunch of infrastructure to support this collaboration, to identify the core features. Like, there's going to be user features, there's going to be product features. In the case of Netflix, maybe, there are, specific features around the films, things like that probably a lot of data scientists are going to want to use. And so the infrastructure team kind of owns, those, not necessarily through some generic infrastructure for, feature reuse, but there are kind of vetted, data pipelines and features for specific entities that everyone's going to want.
Right. And I think that there's a crucial difference between kind of facts and features. So, I mean, like we have a highly curated tables that are easily available and widely shared for facts, for things like, well, I mean, like what kind of movies people watch and so forth. And then like people can derive different type of features easily, like from those. So there's the question that, yes, I mean, like we want to share data. We obviously want to share facts, but and like we occasionally like want to even share code that produces the features. But do we want to share the final features like as is? I mean, that is a trickier question.
Right. So the perspective then to kind of dig into that is a lot of times we think of the features as this monolithic thing, and them being hard to create, and the data scientists spend 80% of their time doing feature engineering and getting the data, and we throw that number around. It sounds like your perspective might be, well, a lot of the challenges in getting access to the facts.
Right.
So if we make getting access to the facts easier, then the features from the facts is more incremental, and that's where your 15 seconds versus 3 hours comes in.
Right. And like when you think about it, I mean, there's the question that like ultimately, like how do you improve the quality of models? I mean, the fact is that oftentimes it is much about data and much about feature engineering. So in a way, I mean, that should be in a way, I mean, oftentimes the center of your attention. I mean, there's nothing wrong about that. So I don't know how it could work if all you can do is to check some checkboxes and say that, okay, these are the features I want to use. We actually want that people apply their domain knowledge and understanding in data and producing the features. We just want to make it very easy to do it.
Okay. So you've got this high performance access to data, and then folks are building out their models in Python. Does Metaflow integrate with PaperMill? Is there a relationship between the two?
Yeah. So now we have Netflix employs actually a number of people who contribute to Jupyter project. And we also recently open sourced another notebook project called Polynote, like very exciting. And like there
Polynode?
Polynote.
Okay, Polynote.
Yeah, polynote.org. And we work closely with them. And it's an interesting question, like how we see that data, like notebooks should be used in conjunction with Metaflow. So actually, as of today, we require that people write the Metaflow code outside of notebooks, and this is a very conscious decision, like for the reason that we still feel that like much of the tooling for producing software is kind of a better, like kind of in kind of a traditional IDEs, and like you have the version control for your code and all that stuff. Now that being said, we support notebooks first class as a way to inspect the results. I mean, that's where notebooks absolutely shine. Sure. That you can
once you've built a library, you can use it in a notebook.
Exactly, totally.
And this is really surprising because I think a lot of us hold up Netflix as the poster child of an organization that is trying to extend notebooks beyond experimentation, even into production.
And actually, like one thing, I mean, like now, like building on that thought that like building these visualizations in inspecting results is so easy in notebooks. This kind of relates to the question of UIs. And interestingly, Metaflow, as of today, doesn't come with any graphical UI per se. And again, I mean, that's a very thoughtful decision based on the realization that like many of the use cases we support have very specific needs. And it would be very hard to have like one size fits all UI that like factually, yes, we could provide some metrics showing that, okay, here's how model converges. And we actually asked data scientists if this is something that they would need or want. And like they said that, well, actually, that's really not the most important thing. Maybe it would be nice to have, but I mean, not the most important thing. And oftentimes I think they want to see something really related to their, like the business question or the model itself. And that's how they want to monitor the results. And what we do today is that we allow people to define exactly the visualizations and the metrics they need in a notebook. And data scientists are more than capable and like actually like really eager to build these visualizations by themselves. And now, since you brought up the topic of PaperMill, what PaperMill does is that it allows one to take a notebook and then kind of render the notebook in a headless manner, like kind of in a scheduling system. So then interestingly, what we get is that we can render these notebooks automatically whenever the model updates, and like we can push it to some location so that you can just go in your browser to some location and you always have a place like where you have a custom visualization of the latest state of your model. So now, I mean, in short, how we use PaperMill, we kind of use tools like PaperMill to basically use notebooks almost as a UI, in addition to using notebooks as a scratch pad. So yes, I mean, like Netflix does a lot of work around notebooks and for notebooks, but at the same time, we are like really thoughtful that like what are the kind of good use cases for notebooks.
Going back to the data scientist experience, when it comes to experimentation, training, model development, what is Metaflow providing there? Yeah.
So one of the first things that we wanted to do well is the support for the local development experience. So in my previous life, I used many other Python frameworks for workflow management like Luigi and Airflow, and they are great tools, especially in production. But it turns out that it's not so easy to actually develop your workflows. The question
is like, heavy-handed when you're trying to run it on your local machine.
So if you think that what's really the fastest way to iterate on something new, it's that like you have a Python script running on your laptop and you can just like keep running it. There's no latency, nothing. I mean, you just hack the code, you iterate, or you do it in a notebook. So that's the perfect experience. And we wanted to replicate that experience with Metaflow so that you can run Metaflow locally. And like you can develop everything, it's super fast and so forth. Now, the next question is that, okay, once you have that local version working, how do you then like even scale it out? Not even take it to production, but I mean, let's say you want to like try it with larger amounts of data. And in some cases, it might be that you just have to re-implement the whole thing, let's say using Spark, which is a fine way of doing it, but at the same time, like requires a bit of a change in paradigm. Also, it doesn't always play nicely with the off-the-shelf libraries like TensorFlow or PyTorch and XGBoost and so forth. So what Metaflow provides is that you can first prototype locally as you would do with any Python script. Then there's a very easy one line of code or like just one command line switch and you can start running it in the cloud with arbitrary amount of resources. And then like with the single command, you can export the whole workflow to a production scheduler so that then it becomes totally production ready and like a part of the overall data ecosystem at your company.
So does the library have its own workflow type of implementation paradigm separate from, something like Argo or Airflow or, Luigi?
Yeah, we do have a local, for the local experience, we do have a local workflow engine. Now, at the same time, like we absolutely like the workflow part is only a kind of a small part, the crucial but small part of Metaflow. So we don't want to become a generic workflow engine. We think that all these off-the-shelf tools, including also AWS step functions, could be a great way to kind of run these workflows in production. Internally at Netflix, we are using a tool called Mason. Like there are a few presentations about it available publicly that provides all kind of a nice operational features like high availability, alerting, UIs, and like you can of course like get something like that from Airflow as well. So the idea is that you can define your workflow in Metaflow, and then you can export the workflow without any changes to one of these production schedulers. So you kind of get the best of the both worlds. You get the perfect local experience as well as the kind of the production grade like workflow scheduling. Then like when you want to do things at large scale on a daily basis.
We're talking about local and then production grade. Is there also a non-local distributed training type of environment that users can push to scale up their ability to train a model?
Yeah. So that's where we really heavily leverage the cloud. Mm-hmm. So the beautiful thing about a system like AWS, and the same thing of course applies to any other cloud provider, is that you can imagine that you have virtually unlimited amount of compute capacity and like storage capacity, and we really heavily rely on that. So you can define your workflow and like you can define the task in your workflow, and like you can add like in our case add batch decorator, in which case we just like take your Python functions and execute them in the cloud using AWS batch in the case of Metaflow today. And we take care of like packaging your code and like sending it to the cloud and getting the data and persisting the data, all that stuff. So the code look exactly like what you would do locally in Python. But at the same time, what's really amazing is that you can specify the resources you want. You can say that, I want 200 gigabytes of RAM, or I want 8 GPUs and so forth. So the abstraction that we would like to have is that imagine that you had a laptop that like with the press of a button, you can just like change the configuration on your laptop. So you can say that like, well, I mean, what if my laptop had like 200 gigabytes of RAM, or what if my laptop had 8 GPUs? I mean, that would be just amazing. I mean, that would be the kind of the ultimate way to do like kind of this development, because you get the low latency as well as like almost unlimited resources. So that's kind of the vertical scalability part. When you just want to get the bigger box, there's of course the question that, well, I mean, what if I want more boxes? And oftentimes what happens in our workflows is that we are not only training a single model, but we are training multiple models. And it might be that, let's say, we train a different model for every country, or it could be that we just want to do a hyperparameter search. So we define a grid of 200 different parameterizations of the model, and then we just fan out everything to the cloud. And like the cloud then like takes care of like building all the models in parallel, and then like Metaflow takes care of fanning in the results, and you choose the model that you want to use.
Kind of like a model parallelism,
exactly,
as opposed to data or
exactly. Compute. And then of course, like for the cases when you absolutely need like distributed models, and this happens, although again it's more of like a 20% use case rather than 80% use case in our case.
Is that roughly correlating to traditional models versus deep learning use?
Question. Not necessarily. I mean, it's amazing. Like even like how far you can get with one big box with the number of GPUs, even with the deep models. But yes, I mean, like of course, like in extreme cases, let's say in computer vision, you absolutely do need distributed learning, like for DNNs, and then like you can we also provide integrations to things like Amazon SageMaker that have distributed TensorFlow built in. Mm-hmm. So that's an easy way. The fact is that distributed learning and like setting up the infrastructure for that is pretty hard, and managing it pretty hard. So what we do is that first, I mean, like we try to remind people that if you don't need it, if you can do it without it. So I mean that's always a good first step. And then if you need it, I mean there are like infrastructure that can take care of it.
You mentioned SageMaker. I was surprised to hear that at the same time that AWS is announcing a ton of new MLOps, ML infra capabilities to SageMaker, experiment management piece, IDE/Studio debugger. They're also, actively promoting what you're doing with Metaflow. Why do you think that they're excited about it?
We think about the data scientist productivity in very much the same way. So Amazon has realized that the kind of the big bottleneck, like for for companies for being able to benefit more from data science is really the data scientist productivity, like more than anything else. And they are heavily investing on improving that situation. Like you mentioned, the IDEs and the debuggers, like all of those things are like a good steps towards increasing productivity. And now there isn't a single formula how to increase productivity. And like what we have done internally at Netflix over the past couple of years, it has proven to work. It is widely used inside Netflix. And Amazon was really excited to see that there is a pattern that really works nicely with AWS. It leverages the best parts of SageMaker and Batch and S3 and so forth. And like we can just make it available to everybody. So I think like we are very much aligned like when it comes to that.
Mm-hmm. So what are the integration points with SageMaker?
Yeah. So like we are working on this integration that would allow you to take any Metaflow artifact. So we like something that like we haven't touched before is the question that like how we manage data inside these workflows. So we automatically persist everything in S3. And one thing about the SageMaker is that it's really amazing, like with all the built-in training algorithms that come with it. But I mean, still there's some kind of a bookkeeping that you have to do to kind of persist the input data in S3 and like take the outputs and so forth. So when you use SageMaker with Metaflow, all that stuff is taken care of for you. So like we handle the S3 management for you. And then you can just basically with one line say that, okay, here's my data. I want to train a model, and then the model comes out, and then you can use it in your Metaflow workflow as before. And what's really exciting is that also in the workflow, you can mix and match different parts. Also, like an important fact is that these machine learning workflows are never only about machine learning. Oftentimes there's the data part, and you may have your training part, and then maybe there's some post-processing, like before you push the results somewhere, like maybe that you write them to a table, or maybe you deploy them as a microservice. So there are a couple of steps after that. So now Metaflow helps you to manage the whole pipeline, and like somewhere in the pipeline, and you can totally leverage SageMaker, and like maybe you deploy to SageMaker in the end. But then like Metaflow is kind of the substrate that combines everything together.
But I'm imagining that there are also a number of areas of overlap. For example, it sounds like while you're not providing a visualization type of an experience for managing experiments, you are managing the experimental data. Mm-hmm. Do you go to any specific lengths to try to make this, smooth for users, what you should use where and when, given that the company is so heavily invested in the AWS tooling and ecosystem, and users will be, it sounds like you've got some fair usage of SageMaker internally.
Right. So, well, I mean, now one thing is that over the past many years, Netflix has been building a lot of infrastructure, like even before SageMaker existed. And like, for instance, for notebooks, we have our own like internal infrastructure, how people can provision notebooks so they can get their managed notebook instances and so forth. And now, given that that's something that Netflix built internally, it works for us. We are using that. At the same time, we recognize that that's not available outside Netflix. It's really deeply embedded in our environment. And that's, on the other hand, something that SageMaker provides. So we feel that, well, it totally makes sense to use SageMaker notebooks if you don't have a managed notebook environment of your own. And now, I mean, we are like evaluating all the new offerings, like what you mentioned about the experiment tracking UI, that we have some like approaches how we have solved similar problems in the past. Now, I mean, they just made the release, and like now we are evaluating that, like where things will go in the long term. So.
Yeah, I'm drawing a lot from the cloud side of things, but my impression has been that, Netflix has always been, hey, if we don't have to do it, we don't want to do it. We'll let AWS do it. Yeah. And so I imagine as SageMaker evolves, you'll be continually evaluating, what pieces of it you'll continue to support versus.
Yeah, I think you're spot on. And I think it's an important, like kind of an important design principle in Metaflow overall, that Netflix is really not in the business for like building this software, and we are not in the business for selling machine learning solutions. I mean, ultimately we want to entertain the world. I mean, that's what we do. We really focus on that one case. And now, so it happens that like an important component of our business goal is to be able to use data and data science. And like, these are the tools we need. So we built the pragmatic tools that like answer like a very pragmatic business questions. And I do feel that many other companies are in the same position, that they are not in the business for building machine learning tools. They are not in the business even like building machine learning per se. They just want to leverage it in their business to improve their whatever business outcomes they have in mind. And I think that's why, I mean, the pragmatic approach that Metaflow has taken, like we can leverage the cloud when it makes sense, like we can just focus on making data scientists productive in like a very practical business use cases, and probably resonates with many other companies as well.
So one of the things that I'm curious about is the flow of projects and use cases onto, into, and out of, off of the infrastructure that you've built with Metaflow and more broadly ML infrastructure at Netflix. You started off by saying that recommendations, wasn't even in scope, right? It's a mature use of machine learning. They've been doing it for a very long time. So it's not something that you are building for. What you're primarily building for are these smaller teams, newer use cases, and correct me at any time, but smaller teams, newer use cases that haven't built up the infrastructure support internally. I imagine that some of those at some point grow in complexity and sophistication and maybe need more than what the infrastructure can offer, and may start to look at building their own things. Or I'm generally curious about the way that dynamic is managed at Netflix and how both the project's use of the infrastructure and the infrastructure evolves.
Yeah. Well, let me illustrate this by kind of giving kind of two metaphors. I mean, one is that production is really a spectrum. It's not the dot that here's the production, but it's a spectrum. And so indeed, we do have use cases that are absolutely business critical, absolutely core to the business, and absolutely must not fail. But still, it might be that the scale is not huge. So it's a smaller scale maybe in terms of the data size, but it's not smaller scales in terms of importance. So it's really a spectrum, or maybe even a two-dimensional plane, where you have different production use cases. That's one thing. Metaflow there covers a certain part of that plane. So, and then the other important thing about this data science project is it's a funnel. So we have tons of ideas, as all companies doing data science, employing data scientists know that all kinds of ideas what you could be doing. What we would like to have optimally is the situation where people can really cheaply test different ideas, experiment. And then the fact is that by design, many of these things actually don't show enough promise that we want to continue the investment, and that's totally fine. I mean, that's how it's supposed to work, and that's why it's a funnel. And then then when you go deeper down in the funnel, I mean, things do graduate, and then things might get bigger and so forth. And again, I mean, now going back to the other idea of the spectrum, I mean, it's totally fine that in some cases you can totally manage the project, operate the project inside Metaflow. And that's what we aim to do in 80% of use cases. Now, in some other cases, if you are super lucky, you go through the funnel, your project becomes super, super important. Also, it turns out that it becomes super, super large scale. I think in those cases, it's totally fine that then we say that now we want to build specific infrastructure for this use case. I mean, there's nothing wrong with that. And I realistically, if you think about any frameworks, that's how it always works. Mm-hmm. So you start with some off-the-shelf framework, you enthusiastically use it, then the company becomes big enough, and then you realize that instead of using this off-the-shelf frameworks, we have to build a custom solution. I mean, that's how it works, and that's the reality. The key thing there is that this happens in a very small fraction of all use cases. Mm-hmm. And it's actually counterproductive to design a system that would theoretically support any use case is one of those special snowflakes. And that's why we are really optimizing for the 95% of the use cases, while acknowledging the fact that maybe then the 5% graduate to a different system in the end.
So you mentioned production as a spectrum, and we haven't talked a whole lot about production. What is Metaflow supporting from an inference perspective?
Yeah. Another important principle, and by the way, we list all the kind of the design principles of Metaflow in our documentation. They're really the kind of the guiding things for our work. Is the realization that in real business environments, these data science projects come in all shapes and sizes. So there isn't one unified grand theory that this is how we always do inference, or this is how we always deploy. There are so many different ways. So sometimes you want to push results to a table where the results get shown by a Tableau dashboard. Sometimes the results are just used by another data scientist in a notebook, and sometimes they maybe power another system as a microservice. And now oftentimes when people talk about the inference and deployment, they only think about the microservice use case. That's one use case, and we do have internal support for that, but that's only one of the use cases, one of the kind of the output modalities that we support. And internally, what we do with Metaflow is that we have this kind of almost as a function, as a service platform that can consume the results of Metaflow pipelines and then deploy this as basically RESTful APIs or endpoints that then custom internal API, web applications can use, or other microservices can use. So this is, of course, a very typical thing, what you can also get with SageMaker hosting service, or there are many other platforms that provide similar functionality. The important thing in our case is that there is a really seamless integration to Metaflow itself. One thing there is that we only do immutable deployments. So all the artifacts produced by Metaflow pipelines are strongly versioned, strongly snapshot as immutable data blobs in S3. And then when we do a deployment, we take one of these immutable data blobs, which might be a model, it might be a data set, and then we push it as an immutable deployment as a microservice. And what this guarantees us is then when you have an internal UI that like uses the machine learning models, we have the perfect lineage that we know exactly that this model was produced by this workflow that was produced by this dataset. And like the important thing here is that the data scientist didn't have to do anything to make this possible, because the fact is that this kind of bookkeeping is a bit boring. It's just, but at the same time, it's super, super important. So we just wanted to make that experience happen out of the box.
So the data scientist doesn't need to be thinking about, Git and using those kind of
that's actually an interesting point
tools.
That you mentioned Git, since we and early on, like there was the question that versioning, like maybe we should use Git, and should we use Git for models? Should we use Git for data? Should we use Git for code? Obviously, Git is a good match for code. At the same time, there's an interesting impedance mismatch between Git and then this like a data science workflows. That are you supposed to make a commit every time you run your notebook? That's kind of not how Git is supposed to be used. The Git history looks kind of ugly if you do that. It's kind of useless anyway. So what we do is that we actually have a built-in content address storage, kind of a Git-like, where we automatically store, like every time you run something, we snapshot your code, we snapshot your dependencies, which is really important. And
what does run even mean in the context of a notebook, though?
Right. Well, in the case of a notebook, it could be like
end-to-end.
Exactly. Okay. Or like in the case of Metaflow, you just take your workflow, you run it end-to-end. And like we persist all of those things automatically. So you don't even have to use Git. And we kind of, there was the idea that, can we just have some kind of a requirement or abstraction that like everybody used it? And it just felt that it just didn't feel quite right. And we decided that, let's build something that does the job while not imposing any additional cognitive overhead, that here's yet another thing that you have to consider. Because I know that if I were a data scientist by myself, I wouldn't like to worry too much. My mind is elsewhere when I'm building the model. I don't want to worry about commits and pull requests and whatnot.
So what is you mentioned that all the artifacts are stored in S3 for models and everything else, but what is the artifact for a model? Is it pickle files, jar files, that kind of thing? Is it containers? What's kind of the currency of a model as it flows through the system? Right.
So by default, and this is absolutely one of the key features of Metaflow, is that in addition of helping you to build your workflow as a DAG, we also manage the internal state of the DAG. So we automatically, when you do something like you have a self.model equals something, we automatically persist that artifact. So there's no need to write lines like store model, load model, store data, load data. And the reason for that, again, goes back to the cognitive overhead, that every time you use a framework that forces you to decide, do I want to persist something? You kind of have to think that, do I want to persist this? Is this important enough? And oftentimes people are just really conservative, thinking that no, I'm probably not important enough. And then what happens is that 2 weeks after you deploy the product, or it has been running 2 weeks in production, then it fails. Then you need to troubleshoot what was going on, and then you don't have the piece of data that you would need to understand what was the internal state of the workflow, so you could actually understand why it failed. And that's why we so enthusiastically persist everything. And since you ask about the format, now again, we don't believe that there is necessarily a single universal model serialization format. So since we allow people to use all kind of frameworks, what we do is that for normal basic Python objects, we use pickle, and if pickle works, that's all good and fine. We also, as I mentioned, we use a content address storage. We don't store copies. We also compress everything. And then for models, let's say you have a Keras model, if the modeling library has a serialization format of its own, we encourage people to use that. So we don't try to abstract away too much, since the realization again is that our users use such a heterogeneous set of different libraries that it would be always kind of a cat and mouse game to kind of try to implement the latest a support for some serialization that someone decided to use. And it turns out that given the additional support that people get from Metaflow, kind of once you have the model, adding the one line there that says that, okay, now I need to save my Keras model, it's not too much work.
You mentioned that model deployment for inference is, at least the microservice-based approach is functions. Is that specifically Lambda, or do you have your own kind of function runner abstraction thing that you've built as part of Metaflow?
So yeah, good question. So this goes back to the previous question you had about like how we work with SageMaker. So Netflix has a very mature container management system called Tidus. It's actually open source. And as a part of that, like we have been developing also a kind of function as a service platform. And like we are using that internally. At the same time, the functionality is very close to Lambda. And like there's actually an open GitHub issue now for Metaflow to see like how much appetite there would be outside Netflix to have something like this available. And like if there was appetite, we could totally do something similar on top of Lambda. At the same time, this goes back to the question that, well, there are many other like tools doing similar things already available, like SageMaker deployments. I mean, maybe if people would be happy to use that, I mean, that would be another avenue like for providing hosting for Metaflow.
So is the idea that the Metaflow that's open source is a subset of the Metaflow that is used internally, with one of the big differences being hooks into these other Netflix projects, and then when you the thing that an open source user would use is kind of scaled back so that it doesn't have the dependency on these other internally used projects. And then if they, if there's enough interest, you might build hooks into the publicly available AWS analogs of those things. Or does Metaflow does it ship with hooks into the other Netflix open source ecosystem projects? Like, how do you manage all of that?
Well,
and I mean, separately, it seems like, potentially a big distraction if your fundamental goal is to support your data scientists and you have these other people wanting to, deploy to Lambda. Like, why do you even care?
Exactly. I mean, that's like honestly the reason why it took 2 years for us to actually open source Metaflow. We like wanted to be very conscious about that question, that like internally, like one of the reasons why Metaflow has been so successful is that like really fanatic user support that we provide. Not only Metaflow comes with really great documentation, including the open source version, but we also support our people on Slack and on chat like really actively. And like we wanted to provide similar kind of experience for everybody. Now, realistically speaking, again, I mean, like we have very finite resources. So we wanted to be really thoughtful, like how we kind of manage the workload. Now, when you ask about like all these other like systems and like how we think about that, well, the fact is that like we released Metaflow just 20 hours ago, and we like wanted to be very open about like what exists today in open source and what doesn't. So you can go to the documentation and check the roadmap. So we have about 5-6 internal components that are not yet available open source, including interesting stuff like a Slack bot and like we have this internal like a data frame implementation, stuff like that. And we want to openly like ask people that like, is this something that like really would be interesting and useful to you? And then we go with that. In the long term, the plan is definitely not to have 2 separate code bases. We are actually like in the first quarter of next year, like migrating our internal systems to use the open source version as well, which is like not that far. The only difference is that like we needed to get rid of these like internal like systems that like practically are not available like outside Netflix.
One thing I'll throw out there, we recently started doing what we're calling democasts, which are kind of like an interview like this, but with a kind of concrete, background being a demo. And if folks are interested and you're interested and open to it, maybe it would be interesting to kind of walk through this and see it in action.
Absolutely. And maybe like this is a good opportunity for me to pitch like one like really interesting feature that we have. So when we open sourced Metaflow, we also realized that our cloud integrations to AWS is one of kind of the killer features of Metaflow. Now, at the same time, we knew that like for many individual data scientists, it would be pretty hard to set up all the required systems in AWS. Maybe they don't even have access to the company's AWS console. So what we provide is this thing called the Metaflow Sandbox that allows anybody to just like sign up for kind of a test evaluation environment. And actually this like works like kind of it's paid by Netflix, and you get your own private AWS environment where you can test like all these cloud integrations like without having to set up absolutely anything in AWS. And the idea with this is that like people, especially individual data scientists, can get the feel that how would it feel like if I had access to this like infinitely scalable laptop and I can just like fan out my compute to batch and like store everything in S3. And then like if they feel that like, well, I mean, this is really something that would increase their productivity, then it's kind of easier to take the little bit of effort that it takes to kind of set up your own AWS account to kind of make this possible. So like if people people are interested, you can go to the documentation and look at the section about Metaflow sandboxes. So it's fully functional. You can sign up today and like kind of get your own private sandbox for a while to use. And like that's just a kind of a segue to the question about the demo. So yes, absolutely. I mean, like I would be more than happy to do a demo with you if people are interested.
Awesome. So if you're interested in that, reach out however you like to reach out to us and let us know, and be happy to do it if there's interest. Quick question on the sandbox. Is there a limitation there? Is this like Google Colab where everyone gets 6 hours, 12 hours, I forget the limit of free GPU instances, or is it only the management plane but not actually instances for training?
Yeah, no, it's actual instances like for training. You get up to a cluster of 8 boxes with 8 CPUs, 64 CPU cores, like a 32 gigabyte machines each. So it's like a decent size. I mean, you can do a lot with those machines. You can like persist any data. You can use it with your own data. This is really important since we have seen so many tutorials and examples in data science where you have something like the house pricing and everybody knows how it works. But like really what resonates with you is your own data and like you understand. Of course, the important thing is that like you shouldn't use anything that's actually privacy sensitive. But I mean, you can get the feel like with some data that like you really care about, and you can do data science as you do it. You can even use any off-the-shelf libraries. We come with built-in integration with Conda, so you can define any Conda packages you want, TensorFlow, XGBoost, you name it, and you can execute these things in the cloud and then see how it works. And the only limitation there is that, well, I mean, first there's no internet connection. We handle the kind of the dependency installation for you, but I mean, the idea is not that you use this to kind of call all kinds of outside services. You don't need that for data science. And then the second limitation is that like, well, instead of like a collab couple of hours, you get 3 days by default. If you need more time, I mean, just reach out to us and we give you more time.
Got it. Awesome. Well, Ville, sounds like an awesome project that I'm looking forward to digging into. And I'm definitely rooting for folks to reach out and, express some interest so that we can get back together and kind of walk through it.
Yeah. Thanks, Sam.
Thanks so much.
Thanks.
All right, everyone. That's our show for today. To follow along with our reInvent series, visit twimlai.com/reinvent2019. Thanks once again to Capital One for their sponsorship of this series. Be sure to check out CapitalOne.com/tech/explore to learn more about their ML and AI research. Thanks so much for listening, and catch you next time.